When solving a quadratic inequality, we must first set it to 0, just like you do with equations. And then, if you can, you will factor it, just like you do with equations. And let's see, 2x and x plus 4 minus 3. So this does indeed factor. This pen. There we go. Now, a mistake that's often made is that students will do this. This is a no-no. And solve it like this separately. Either the 2x minus 3 is greater than 0, or the x plus 4 is greater than 0. That is wrong. And the reason is because we are multiplying 2x minus 3 by x plus 4, and that answer must be greater than or equal to 0. So we can't treat these separately, because the only way it will be greater than or equal to 0 is if 2x minus 3, that part of it, and x plus 4, that part of it, are either both negative or both positive. If the value I insert in for x makes one of those quantities positive and the other one negative, it won't work. And if you do these separately, you're going to run into that issue. So what you have to do is you have to figure out which values of x make both 2x minus 3 and x plus 4 negative, or 2x minus 3 and x plus 4 positive, or of course what makes them 0. And that last part is the important part. The thing you should do before you do anything else is to determine when it's 0. And it is 0 at 3 halves, because 2x minus 3 equal to 0 at 3 halves, and negative 4. Any other value you plug in for x will give you a positive or a negative product when you multiply them. 3 halves would give you 0, and negative 4 would give you 0. Those are the only two numbers that if you plug those in for x, would give you a product of 0. So we're going to use what's called a sign chart. Look at this. There we go. So in the sign chart, we are going to put on the number line the two values that make this 0, which we determined would be 3 halves and negative 4. So I'll put a big 0 above both of those. This pen is driving me crazy. There we go. So if I plug in a value for x greater than 3 over 2, any value, 2, 3, 4, doesn't matter. If I plug in, let's say 2 into 2x minus 3, I would have 1, because 2 times 2 is 4, and 4 minus 3 is 1, times 6. They're both positive, so that means that they will make a positive when I multiply them. That's what I want, both of those quantities to be positive, but I also want them both to be negative. That also works. So let's try a number between negative 4 and 3 halves. The easiest one would be 0. If x equals 0, I have negative 3 times 4. Okay, that's what I don't want. One of them positive and one of them negative, because then they'll multiply to a negative number. And if I try a number less than negative 4, let's say if x is negative 5, that would give me negative 13 in the first one, and negative 1. They're both negative. That means when I multiply them, I get a positive. That's what I want. So my solution will be everything that makes the product 0 because I can equal 0, or what makes it greater than 0, which means positive. So that means all of the numbers up to -4, including -4, and starting again at 3/2 and going to the right to infinity. So the solution would be -infinity to -4, hard bracket, union 3/2 and onwards. The only time one of those numbers will be positive and one of them will be negative is if you use a number between -4 and 3/2. We're done.